Hello everyone, welcome to our channel Satya's Chemistry. Today in this lesson we are going to learn LAQ from chemical bonding. Here is the LAQ, that is, what do you understand by hybridization? Explain different types of hybridization involving s and p orbitals. Definition of hybridization is, hybridization means the process of intermixing of two or more different orbitals of nearly equal energy to form identical hybrid orbitals having same energy is called it as the hybridization. What it means? Intermixing of two or more different orbitals which has the nearly equal energy. Okay, intermixing of two or more different orbitals which has the nearly equal energy to form identical hybrid orbitals which have the same energy. Okay, is it clear? In hybridization, what the result in? Hybrid orbitals which has the same energy. Then number of hybrid orbitals formed is equal to number of atomic orbitals intermixed, or number of atomic orbitals intermixed. Okay, number of hybrid orbitals equal to number of atomic orbitals intermixed. The different types of hybridization involving in sp orbitals are sp, sp2, sp3. How many hybridization we are learning in this session? We are learning 3 hybridization. What are those? sp hybridization, sp2 hybridization, sp3 hybridization. So we are good at the definition of hybridization, right? Now we are going to learn what is the meaning of sp hybridization. Okay, sp hybridization means one s orbital and one p orbital intermix to form two sp hybrid orbitals. We call it as a sp hybridization. What is the meaning of sp hybridization? Sp hybridization means one s orbital and one p orbital intermix to form sp hybrid orbitals. Okay, in sp hybridization, s percentage is 50 and p character is 50. Geometry of this sp hybridization is linear. Bond angle is 180 degree. Example for sp hybridization is barium chloride, acetylene and carbon dioxide. Is it clear? Now we will see how the sp hybridization is. See here, this is the s orbital and this is the p orbital. These two orbitals intermixing and forms sp hybrid orbitals. Okay, intermixing of these s and p orbitals forms sp hybrid orbitals. So how many hybrid orbitals are there? 2 hybrid orbitals there. Why? Because one s orbital, one p orbitals are participating in hybridization. For example, if we take the barium chloride, in barium chloride the central molecule is beryllium. Electron configuration is 1s2, 2s2. In first excited state, what happened? The electron from s orbital shifted from here s orbital to p orbital. How many lone pair electrons are there here? 1, 2. One is from to s orbital, another is p orbital. Okay, so these two orbitals participate in sp hybridization. Okay, the resultant sp hybrid orbitals. See, this is participating in sp hybridization. The resultant sp orbitals of beryllium overlaps axially with p orbitals of chlorine atom to form 2 sigma bonds. See, this is the sp hybrid orbitals of beryllium. These beryllium atoms hybrid orbitals are axially overlapping with chlorine p orbitals. This is the chlorine p orbital of chlorine. This is one chlorine atom and this is second chlorine atom, are axially overlapping to form BeCl2. How many sigma bonds are here? 2 sigma bonds are there. What are those? One sigma bond here and second sigma bond is here. The bond angle in barium chloride is 180 degrees. Shape is linear. Okay, is it clear? How many sigma bonds are present in barium chloride? 2. What here is 1 and here is the 2. Shape is linear. Hybridization is sp. Coming to the next hybridization, that is sp2 hybridization. In sp2 hybridization, one s orbital and 2 p orbital are intermixed to form sp2 hybridization. Okay, in sp2 hybridization, how many orbitals are participating? three atomic orbitals are participating. One is s orbital, another two are p orbitals. Okay, so in sp2 hybridization, shape is trigonal planar, bond angle is 120 degrees, and the number of sigma bonds are 3. Here is, this is the s orbital, and this is the px, one p orbital, and this is the another p orbital. These two p orbitals are intermixed with s orbital and forms sp2 hybrid orbitals. For suppose if the example for this sp2 hybridization is BCl3. Okay, formation of BCl3. In BCl3, the central atom is boron. Ground state electron configuration for this boron is 1s2, 2s2, 2p1. See, in first exit stated, what happened? This is the 1s2, this is the 2s, and this is the 2p. In the first exit state, the second electron of this s orbital moves to here, and this is the px orbital already, py, pz. This one s orbital, two p orbital participate in hybridization and forms sp2 hybridization. Okay, in the excited state, central atom of boron undergoes sp2 hybridization. These sp2 orbitals, three sp2 orbitals, see here 1, 2, 3, three sp2 orbitals of boron overlaps with p orbitals of chlorine. This is the p orbital of chlorine, and this is the p orbital of chlorine, and forms three sigma bonds. One is sigma bond here, and second one and 3 here. Okay, this is the BCl3 or boron trichloride formation. In BCl3, hybridization is sp2, shape is trigonal planar, bond angle is 120 degrees, and number of sigma bonds are 3. Coming to the sp3 hybridization. What happened in sp3 hybridization? In sp3 hybridization, one s orbital and 3 p orbitals participate in sp3 hybridization. In sp3 hybridization, one s orbital and 3 p orbitals mix to form 4 sp3 hybrid orbitals. In sp3 hybridization, s character is 25%, p character is 75%. Geometry is tetrahedral. Bond angle is 109 degree 28 minutes. Here is the 1s orbital, 1 p orbital, py orbital, pz orbital. These 4 hybrid atomic orbital intermix to form 4 sp3 hybrid orbitals. Is it clear? So these are the 4 sp3 hybrid orbitals. Formation of methane molecule. But suppose in methane molecule, the central atom is carbon. Ground state electron configuration of this carbon is 1s2, 2s2, 2p2. In the first excited state, what happened? In the first excited state, see, this is the 1s2. S orbital, one s orbital has a 2 electron, and this is the 2s, and this is the 2p. In the first excited state, already p orbital has 2 electron. What happened? This s electron move from here to here. This is px, this is py, this is pz. These 4 orbitals, atomic orbitals, 1, 2, 3, 4, intermix to form 4 sp3 hybrid orbitals. Okay, and in these 4 sp3 hybrid orbitals of carbon axially overlap with s orbitals of hydrogen. This one is s orbital of hydrogen, and this is the s orbital of hydrogen, and this one is s orbitals of hydrogen, and here is the s orbital of hydrogen, to form 4 sigma bonds. Here is the 1, 2, 3, 4. Okay, is it clear? This is the sp3 hybridization. In methane molecule, hybridization is sp3, shape is tetrahedral, bond angle is 109 degree 28 minutes, number of sigma bond is 4. Okay, is it clear? This is all about hybridization, sp, sp2, sp3. Coming in hybridization, in this question, you should memorize the definition of definition of hybridization, and then if you are good at this definition of sp hybridization, it is easy to write another hybridization. Why? Because in sp hybridization, one s orbital, one p orbital is there. In sp2 hybridization, one s orbital and two p orbital mix to form three sp2 hybrid orbitals. And second thing, in this, for this answer, you should write these points. What is the hybridization? What is the shape? What is the bond angle? And what is the sigma bond? How many sigma bonds are present in a given molecule? You should, for this question, you should write definition of hybridization and definition for sp, sp2 and sp3 hybridization, and you should give one example. Okay, is it clear? If you like my video, please subscribe, share and like. Thank you.